Hello. In this particular part of trigonometry, we're going to look at using algebra to simplify our trig expressions. And the first skill I want to go over with you is how to factor using trigonometry or given trigonometric expressions. And so the first type I want to look at, I'm going to look at problems number 1 and 4 first. These are called quadratic equations because of the square involved. And also, if you look at them, they fit that pattern. You have the sine squared and then a single sine and then a constant. Down here at number 4, you have a cosine squared and then a single cosine and then a constant. That fits that pattern of a quadratic equation, ax squared plus bx plus c. There are any number of ways we can factor, but generally speaking, when we have three terms, a trinomial, we try to break it up into a couple of different factors there. So I want to do number 1 and number 4 first. So when we do number 1, what we're going to do here, because that is a square, that's the telltale sign, is we're going to try to see, well, before I even do that, I want to look at the coefficients or at the terms in general, not even just the numbers in front, but let me start with the numbers. And you see here that 4, 8, and 4 can be divided by 4, so I want to factor that 4 out. Now, if you look at the sine squared and the sine, and then the last term doesn't have a sine, there's nothing else they have in common. So you couldn't factor the sine out, but you could factor the number 4 out. So when you factor that 4 out, this term, it's like you're dividing by 4. So that reduces to just sine squared y. And if you factor a 4 out of here, it leaves you with 2 sine y to make that 8. And then, of course, if you factor the 4 out of 4, again, it's like dividing by 4. That leaves you with just a plus 1. And you can check that. If you distribute that 4 across all three of those terms inside the parenthesis, you do get 4 sine squared y plus 8 sine y plus 4. Okay? Now, you're not done because you still have a square here. So if we still have a square there, we want to try to break it down further. So generally, if we have a trinomial, we put 2 sets of parentheses up here. And the first step is to try to figure out how to get sine squared y. So to get sine squared y, that means you have 2 sines. We can put a sine y here, and we can put a sine y here. Okay. The next thing you want to do is look at this last term. We want to get a positive 1. So what times what gives you a positive 1? Well, a negative 1 times a negative 1, or a positive 1 times a positive 1. We want to go with a positive 1 here. See how that gives me a positive 1? And we want to go with a positive 1 here because your middle sign is positive. You want to get a positive middle term. Now, to check yourself, what we do is we FOIL it to see if we're right. So some people can do that mentally. Let me just show you what we're doing, like concretely here. So if you multiply those two together, you would get sine squared y. Note where we put the power. If we do sine y times 1, we get 1 sine y. Same thing in the middle. 1 sine y, and then the 1 times 1 gives me a 1. So that does, if you collect the similar terms here by adding your coefficients, that does give you what we had to begin with. And then if you multiply through by that 4, you'll see that you do get what we had originally. So it's a matter of just trying to figure out what to put in this first spot to get the first term, and what to put in the second spot to get that final term. Now, the decisions you make have to FOIL out to give me that middle term. So you always have to pick things, but then you have to check. Okay, So let me move to number 2. Number 2 is another factoring question. And basically, again, we know we're done here because you have made it into a situation where you don't have any more squares in your problem. You don't have any more powers. Everything's to the, see how sine y is to the first power? Sine y plus 1, you can't break that down anymore. So that's how you know you're done. Now, number 2, if you look at your numbers, you don't have anything in common, nothing that divides into all 3 of those numbers, okay? And you don't have, like if you look at your cosine function here, you don't have cosines in all 3 of your terms. So there's nothing you can factor out there. So because that is a square again, we write down 2 sets of parentheses and we concentrate on that first term. Okay, and by first term, I mean that's the term before you get to another minus or a plus sign. So we look at that separately. So for me to be able to get something that multiplies out to be 2 cosine squared x, I could do this. I could put a 2 cosine x here and a cosine x there. So if I multiply that, that does give me 2 cosine squared x. Okay, so that works for that. So now I'll move over here to my 3. You skip the middle term, go to the 3. Now, okay, so I can do 3. I can do 1 and 3 because I can, a 1 times a 3 gives me a 3. I could also do 3 times 1, but let me see if 1 times 3 works. You see how that's a positive 3? So my signs here have to be the same. So I could do a positive 1 and a positive 3. Or I could do a negative 1 and a negative 3. Now, here's what will help me decide which ones to do. If I go to that middle sign, since that is a minus, I'm going to choose to do a negative 1 and a negative 3, or a minus 1 and a minus 3. So see how those two, if you multiply them, that still gives me a positive 3. Now, let's see, because I'm not sure. I could have put the minus 3 on the first set of parentheses and the minus 1 on the second set of parentheses. I'm not sure if I'm right or not. So I want to FOIL it out to check my math there to see if I chose the right thing. And again, some people can do this mentally, and it looks like they're just, I don't know, it looks like maybe they know more than you do, but they're just doing quicker mental math. So if you're not there yet, it's okay to just go ahead and check yourself. So if we FOIL this out, that 2 cosine x times cosine x is 2 cosine squared x. And then 2 cosine x, now remember that's a negative 3, minus 3, same thing as a negative. So that gives you a negative 6 cosine x, 2 times 3. Then if we go to the inside, a minus 1 times a cosine x, or a negative 1 times a cosine x, is a negative 1 cosine x. And finally, the last term's a minus 1 times a minus 3, or a negative 1 times a negative 3 is a positive 3. Now, adding those middle terms together, remember when we're adding, we just add the coefficients. So a negative 6 and a negative 1 make a negative 7. And then you want to see, is that the same thing that you had up here? And yes, it is. So I got lucky. If that did not work out, I would probably put the 3 on the first parenthesis and the 1 on the second one to see if that would work. So that's the process. Some people are quicker at it than others, but basically this is my answer right here that I'm highlighting in blue. I have factored that because I have written it as a multiplication expression. And you see how the cosine x is not squared anymore. So I've broken it down to its simplest form. Okay. Now here's one that doesn't have 3 terms. So this is the type that I remember from algebra that's in the form a squared minus b squared. And when you have squares or even powers, like yours is not a square, but yours is an even number, then you can use this formula to break this down into a plus b times a minus b. Now that's a formula we learned back in Algebra 1. So how does that translate to this being a 4th power instead of a square? Well, it's the same idea. You're going to, as before, you're going to try to get sine to the 4th. So we split it in half. we put a sine squared here and a sine squared there. And as the formula says, you can do plus minus, but it's okay to do minus plus. That doesn't matter. And then we come here and we want to get cosine to the fourth. So again, we break that, we split that up to give us a cosine to the fourth. So I can do that by putting a cosine squared x here and a cosine squared x here. And you see if you FOIL it. Let's again remember we got to check ourselves. So this times this. When you multiply, you add your powers together. So a square and a square makes a fourth power. Sine squared times negative cosine squared gives me a negative sine squared x, cosine squared x. Inside, I get cosine squared x times sine squared x, which is, and they're both positive, and I can write that in any order I want to. So I'll put the sine squared x first times the cosine squared x. And then finally, the last terms, you have a positive times a negative, which gives me a negative, and adding the powers, because I'm multiplying, gives me a cosine to the fourth. And you see that these two terms that I'm underlining are, one's a negative, and I could say that that's a -1. And over here, this is the very same term, except it's a positive one. So these terms cancel out. And it does give me what we had to begin with. Okay, so now, what I have got is sine squared x plus cosine squared x times sine squared x minus cosine squared x. And basically, for the first time, we're not done with this yet. You again have in this problem something that fits this pattern. So I can break it down some more. I cannot break down the plus one anymore. I can't factor it so that it will break down, but a -1 you can. So you can break this down. A -1 you can, I should say, so long as those powers are even. So sine squared x, I'll make that again, break it down to just sine x times sine x. Remember, either plus minus or minus plus. And cosine squared x, I can break down into cosine x. So this is now fully factored because I can't break anything else down any further. Okay, so that's another type similar to 1 and 2, but yet requires a couple of steps to get it fully factored. And now this one is not a traditional factoring trinomial problem. This only contains 2 terms, but unlike the third one, it's not a minus, and it doesn't have the same, the even powers throughout. This one is kind of like the first one, where we do have a greatest common factor. So if you look at this term and this term, what they have in common is a cosine x. So you can factor out a cosine x. And when you take it out of the first term, it leaves you with sine x. And when you take one of the cosines out of cosine squared, it just leaves you with 1 cosine x. That's also factoring. Anytime you're making it something times something, you have factored it from a sum, in this case, to something times something. And you can't simplify any of those anymore because you don't have any more. You don't have squares or higher powers in your problem, so there's no possibility of simplifying that anymore. Factoring is important in solving equations, which we'll get to later, but also in simplifying. So here's one that we could factor numerators and denominators and possibly get something to cancel out. So let me show you this one. So if we just look at this problem, that is a problem that's in the form a squared minus b squared. Okay, so I can break that up. And I can break the 9 cosine squared into 3 cosine. You see how I'm writing the same thing down again. That's when you have what we call perfect squares. This has to be a minus. So I'll do, to get a negative sign, I need my signs to be different. And 25, I break into 5 and 5, same numbers. That denominator, it's not a cosine squared, but before I even look at that, I see that they both have a 2 in common. So I can take a 2 out, and that will leave me with just cosine when I take the 2 from this term. And then if I take the 2 from this term, remember it's like you're dividing by 2, so you have to say minus 1. All right, now moving to this numerator, again, because that is a square and that is a minus, you can do that same thing again. So we break cosine squared theta up into cosine theta and cosine theta, plus minus, and we break the 1 up into just 1 and 1. The denominator, finally, the 6 and the 10 can both be divided by 2, so I factor a 2 out, and 2 times 3 is 6, so I will put 3 cosine theta down to get my 6 cosine theta. Put your minus down, and 10 divided by 2 is 5. So you see what I've done is I've just factored everything. So there are like 4 problems there. And then because you are multiplying here, you just cancel any common factor that's common to the numerator and the denominator. So I see 3 cosine theta minus 5 can cancel out. And the reason I can do that is because that's equivalent to 1. And then over here I see cosine theta minus 1 factors out. Again, that's equal to 1, so I can kind of take it out. I can reduce it down. And I don't see I don't see anything else I can take out, because 3 cosine theta plus 5 doesn't appear in the denominator. Cosine theta plus 1 doesn't appear in the denominator, and I don't have a 2 appearing in the numerator. So it looks like I've matched up everything I could. So we write down what's left. So in the numerator, I have 3 cosine theta plus 5 times cosine theta plus 1. And in the denominator, all I see is a 2 here and a 2 here. And remember, you're multiplying. So 2 times 2 is 4. So you have multiplied that fraction, but before you multiplied, you reduced it so that it wouldn't be so awful to multiply. So factoring is a tool for multiplying as well. Now here's one that is just one fraction. So what we're going to do here is factor here because of that square and because that's a minus. And this will help us to reduce that. Now remember, you can't cancel your cosines out here because you have minuses and pluses here. You can only cancel when you're multiplying. So you have to do the factoring process before you cancel stuff out. So in the numerator, don't even look at the denominator, but in the numerator, the cosine squared I can break up into cosine theta here and here. And again, because that's a minus, I can do plus and minus or minus and plus. And then a 1 I can get by doing a 1 and a 1. The denominator, I can't simplify any further because that's cosine theta to the first power. So you have factored now. Now once you've factored, you look and see if you've got something common to the numerator and to the denominator. And you do. This factor is the same as that. So we can reduce that because that's equivalent to 1. So finally that simplifies to cosine theta minus 1. So learn how to factor using trigonometry. But we're basically adopting your old algebra skills, the reverse FOIL and the formulas to help us break things up. And that's a useful skill when we're learning how to solve equations, as you'll see later on, or in this case, how to simplify things.